I would like to welcome you to the first public event of the International Space University Space Studies Program. Please welcome Professor Hoffman.
Well, thank you. I think it's important just to remind ourselves, why do we want to put a telescope into space anyway? If you go above the atmosphere, you have a much greater view of the entire electromagnetic spectrum and without the disturbance of the atmosphere. So the hope was that we would be able to get an unprecedentedly clear view of faraway galaxies to really understand the nature, the structure of the universe. The dream of the Hubble telescope was to make a telescope that could be serviced by astronauts in spacesuits working out of the space shuttle. If in order to make a mirror which focuses all the light at the same point, you have to make what we call an aspherical mirror, so that all of the light, whether it falls on the outside of the mirror or the inside of the mirror, it's all focused at the same point. Once you do that, the basic way that the telescope works is there's a hole in the middle of the mirror. The light hits the big primary mirror, is reflected off a secondary mirror through the primary mirror, and comes to a focus back here behind the main mirror. And then that's where you put all of your observing instruments. In the spring of 1990, the Space Shuttle Discovery did take the Hubble telescope up and put it into orbit. And after a couple of weeks, it dawned on people that this was about as good as Hubble could focus. It was a real shock. It was a catastrophe for NASA, for the astronomical community. In order to solve a problem, first of all, you have to understand what the problem is. So you start out with a big piece of glass. Above the mirror, in the focal plane of the mirror, you put another small telescope, which we call a null corrector. In the middle of this null corrector, you put a measuring rod, and that has to be positioned very, very precisely. What they did was to put an end cap on the end of this metering rod, and there was, in the middle of that end cap, there was a little hole, and then you could shine a light down on it and measure the distance to the top of that metering rod, and that would assure you that you were in the right position. They went to the company in Connecticut where the mirror was made to look for the metering rod and the field cap. The anti-reflective coating, which is all over that entire field cap, right around that little hole where the light was supposed to go through, had peeled away. The light was supposed to reflect off the end of the metering rod. Instead, it reflected off the end of the field cap, and the metering rod ended up about 1.3 millimeters too close to the mirror. Light was not focused at the same place, and you had classic spherical aberration. What can you do about it? Instead of letting the out-of-focus light bounce off the mirror into the science instrument, you had to install 2 extra mirrors, each of them about the size of your thumbnail. There were, in addition to the corrective optics, there were a lot of other things that had gone wrong with Hubble. The solar panels weren't working right. Some of the tape recorders had failed. And it was going to take 5 spacewalks. NASA had never done 5 spacewalks in a mission in the entire history. This is the image that we had of the Hubble telescope. It's really big. It's about 15 meters from top to bottom. And this was just an incredible, floating up there. You're suspended between heaven and earth. We had actually replaced the corrective optics. We had put in new solar arrays. Would the corrective optics that we had installed actually do the job? It worked. And of course, the rest is history, because Hubble, as you know, has gone on to just produce these, one after the other, these iconic images that everybody around the world has come to know and love. The reason that the Hubble telescope has been so productive scientifically is because of servicing. When Hubble was launched, even if its optics had been perfect, it carried 1970s instrumentation. Now, Hubble is a 21st century satellite with almost 1,000 times the sensitivity of what it was launched with. That's the real value of servicing.